How many? I know a lot of you have missed it, have gone back and made up, and I try to keep on top of what you've told me. At some point here, I'll actually post absences to each of you again that haven't been made up. So you can say, wait, I watched that, or you can say, okay, I'll go watch that.
So we have to let you know if we watch.
You have to let me know that you watch it, because I have no way of knowing otherwise.
Perfect.
How have the lectures been? Has quality been sufficient? I mean, it's a cheap camcorder. I really need to buy a new one. Okay, that's all I care about. Accelerate. As I mentioned, this is first semester. Oh yes.
So we watch podcasts as well, right? In addition to like lecture and stuff. One thing that I did like about the podcast that's kind of different from yours is how the way he sets up his slides. Because sometimes with the video, it's a little bit hard to see like what's actually on the slide.
Yeah.
Like when you're watching it later. So.
That's true, but I always put the slides up on it.
Oh, you can.
On their website, you can put the slides up and watch through them. I agree, but on the other hand, Chuck was a tenured professor who could do that on his own paid time. I'm an adjunct professor. I don't do this for the money. I mean, money. I don't turn down the money, but yeah, adjunct professorhood is not a way to make a living. Let me just say that right off the bat. So I do this because it's fun. It keeps me fresh. It looks really good on my resume as an expert witness, to be quite honest. Okay, I am a professor. I actually had a case this year where the lawyer who retained me kept calling me Professor Webster, and I finally had to say, you can just call me Bruce, you really can. You know, you're a lawyer. Anyway, as I mentioned, I may edit all that out. As I mentioned, at the start of the semester, this is first semester I've used this book. This summer I was part of a consulting group that spent several weeks putting together for a multinational corporation out of Europe a set of recommendations for moving to next generation software development practices and technologies. To be honest, a lot of what we ended up recommending were things that I had not worked with before, but learned an awful lot in the process. It was one of the other consultants who suggested I get and read this book. I was impressed by this book because it's based on actual research. A book I used to use, which I still highly recommend, it's on the extra credit reading list, is Facts and Fallacies of Software Engineering by Robert Glass. And Glass is the same way. He documents most of what he lists as the facts and fallacies, and one of the things he points out is that an awful lot of what ends up being recommended or recommended against in software engineering is sort of based on gut feel and because it seems to make sense, as opposed to any actual studies that say yes, this helps, or yes, this hurts. So with the group behind Accelerate, they actually, let me go to the first slide. They actually collected data from over 2,000 organizations over a 4-year period. So they had a number of self-assessments, which they talk about in the book. I trust that you have read the book, so I'm not going to sit and recapitulate the whole book. I'm not even going to recapitulate my slides. But they basically surveyed a bunch of organizations, had various questionnaires to determine first whether or not they qualified as a high-performing organization, and second, what were their practices, how did it work. And the book is based not on, we have great thoughts and we think this is the best way to do it. The book is based on, here's what the high-performing organizations did and didn't do. Here's what the low-performing organizations did or didn't do. So it's good evidence-based stuff. I want you to be aware, even on, and this is where I feel like I'm up on a trapeze without a safety net. I have not practiced most of the things that we will discuss out of this book. I've not done DevOps. I've not done continuous integration, continuous delivery. I've not lived in a fully automated test environment and so on. But my colleagues that I was working with this summer have. It is pretty much how they're all very active in doing software development at a high level at a number of different locations. And these are practices they could put into practice again and again. So they talk about 5 things, just basically the 5 things that are going to be for the whole book, so that's not really the thing here. Okay, so what do they mean by a high-performing acceleration? Fast delivery and delivery that's very satisfying to the customers. They use the term to life. The ability to respond quickly to market situations. The ability to respond quickly to compliance and regulatory changes. And the ability to respond quickly to market risks. Meaning, you know, suddenly some new competitor came out who's got a set of features that you don't have, and everyone says, oh, this is the next great thing, and suddenly you're old news. That happens all the time. So, DevOps, this is not a full lecture on DevOps per se. In fact, we're only going to sort of wave our hand as it goes by. But the basic idea is that you don't see development and operations, meaning actual deployment, as 2 separate entities. They're very tightly integrated. And what you have is this. How many of you have and there are backfires to this. How many of you are on Facebook? I know it's kind of old hat now. Anyone? Okay, you're really committed. You're on Facebook still. Have you noticed it's gone away some, but particularly a couple of years ago, Facebook was very big on DevOps and multiple releases and so on. And you'd literally be using Facebook and suddenly something would change that was working differently an hour earlier. And occasionally something would change and break stuff that was working an hour earlier. Okay? Y'all been through that? Yeah. Okay, that's this continuous development, continuous integration, DevOps type work. There's a book that's a fictionalized version of going from traditional software development to DevOps called the Phoenix Project. Anyone read that? I should probably put it on the extra credit list. You know, as fiction, it's polemic. It's sort of the Atlas Shrugged of software engineering. Anyone here actually read Atlas Shrugged? Oh, good for you. No, good for you. Well, it's a little heavy-handed and so on, but the first part of the book is like a software engineering horror story. and what makes it so horrible is that it's so true to life. I mean, it's sort of, it describes situations and managements and practices. It's sort of like the worst of everything, but almost all of them are situations that I have at least encountered in one degree or another in different jobs. Just not all of them in the same place at the same time. If you want an entertaining read that may scare you out of going into software engineering, read that. Okay, so their focus is software delivery performance, which they talk about of how quickly can you build, test, and deploy. You have a change you want to make to a system that's in production. You need to, change the code, rebuild it, test it, and test it sufficiently that you are willing to let it immediately go live. They define, these are their definitions for a high-performance organization. Lead time of less than an hour. That is, once you've made the change, it takes less than an hour to get it in production. You can deploy multiple times a day. Mean time to restore means you can back out the change in less than an hour. This was what particularly Facebook was going through about 2 years ago. Something would suddenly start acting weird, it'd be broken, and then suddenly, about 2 hours later, it'd be back to what it was before. And the change fail percentage means making those changes and not having it break something. Now, their observation is that software delivery performance impacts 2 key things. First is the organization's performance as an economic entity. Profitability, market share, productivity. It also impacts its performance in terms of goodness. In other words, the quality of the goods, the efficiency, customer satisfaction, organizational satisfaction. They also have a little section there which simply echoes something I've already told you guys. When do you buy, when do you build? You buy what's necessary for minimum standard of competition. You don't build your own accounting systems. You buy accounting systems. You buy HR systems. You build for that which is your unique invention. In other words, you buy the stuff that's we're back to armor, always back to armor. You buy the stuff that's already been done and you can get off the shelf or get as a service. You build the stuff where you're doing the exploration and the invention, and you've spent the time and you've gone down the wrong path, but you've learned how to do things that other people don't know how to do yet. Any questions, comments, feedback? Yeah.
What is CFTS stand for?
Oh, commercial off-the-shelf software. That's like Microsoft Word. SAS stands for Software as a Service. That's stuff like Salesforce and so on. COTS is stuff you get. That can range literally from an app on your phone to something as massive as, say, SAP, which is Enterprise Resource Program System, which needs significant configuration and, frankly, usually coding for any implementation. Any other questions? Yes?
Do we even have any more like commercial off-the-shelf software? I feel like everything just download, like even with Windows, it's just Windows 360.
Well, that's a good question. You mean, is there stuff you go off and buy CD-ROMs for? Not often anymore. Doesn't mean it isn't COTS. If you buy Windows 365, it's COTS because it's off the virtual shelf. Now, the fact that you download everything, I mean, Steam. How many of you are on Steam? Okay. What do your archives look like? Okay. Those are all COTS programs. Doesn't mean you don't get updates, but it's not a service. You pay for it, you download it, you install it, you uninstall it, you can go back and reinstall it if you want it, but it's off the shelf, meaning there's no custom coding or configuration required to actually use it. Yeah?
Would Netflix be more like software as a service?
Actually, you could consider Netflix sort of software as a service, yeah. Most of the streaming things, there are, and it's sort of, there's an eternal pendulum you guys are going to deal with because I've been watching this for 40 plus years. The pendulum basically has two main states. One is you're running everything locally. The other state is you're running everything remotely. This was actually one of the earliest days because it used to be you would be on a terminal or a teletype machine that was off talking to a mainframe somewhere. And the big invention was the actual advent of mini computers so you could run stuff locally. And then you sort of swung back to servers, and then you swung back to PCs, and then you went back to thin clients and web apps and stuff like Chrome, and then you went back to apps, and it sort of goes back and forth. And I could spend another half hour talking about why that happens, but we won't. But just be aware this goes back and forth, and there are a lot of blurred lines as to what they are. Okay, this may be one of the most important chapters that you read out of the whole book. Because it doesn't have to do with the specific technology or practice, it has to do with the culture of the organization we're in. Now, I'm going to skip right ahead to the next slide. We'll go back to this one. This model, let's get it, Westbrook, something like that, has three models of organizations: pathological, bureaucratic, and generative. And these are the things that characterize each of the organizations. And once again, you can certainly have bleeding across and some that's half one and half the other and so on. But pretty much what you got here, I should go with the laser point. Over here, I always forget to have a laser point. Pathological, power-oriented. It's all about empire building. You have low cooperation within the organization. Messengers, meaning messengers bringing bad news or shock. You all read thermocline of truth. This is why the thermocline of truth exists. No one wants to hear bad news. People shirk their responsibilities. Bridging, meaning cross-fertilization, cross-cooperation among different organizations is discouraged because, again, it's all about the empire. It's all about the silo. Failure leads to scapegoating, meaning this is the classic, blaming the innocent for the failures. And novelty is crushed. That's not how we do it here. Okay, rule-oriented, you have some degree of cooperation. Messengers aren't so much shot as ignored. They're there. We'll get it done. We know we can do it. Responsibilities are there but are narrow. They'll tolerate some degree of cross-fertilization. Failure leads to justice, which means if there's a failure, at least it's the person responsible who's blamed rather than the people who aren't responsible. And they see novelty as a risk. Generative, and if you haven't guessed, this is the high-performance one. You have a high degree of cooperation. Messengers are trained. Now, when we talked about the thermocline of truth, we talked about, what do you do to pierce the thermocline? You have to reward people for coming up and telling you the bad news in the trenches. And there are organizations that do that. Or better yet, the people up above will go down in the trenches. As I said, when I have to review a troubled project, first thing I do is I interview everyone. And I especially interview the people in the trenches. And once I have talked to maybe 4 or 5 engineers, I can pretty much tell you what's going wrong and how far along the project is. Because I start to hear, usually, with a few you'll have outliers, and some their stuff will be going great and so on. But once you've talked to 4 or 5, and particularly after about half a dozen, it's kind of like, okay, I'm hearing this story. I've heard it from 3 different people. It's consistent. I know pretty much the problem is. Risks are shared. In other words, people are trying to help each other succeed. Cross-fertilization is encouraged, not discouraged, not tolerated, but encouraged. Failure leads to, why did this fail and how can we avoid it in the future? Failure is a necessary aspect of growth. It's how you learn. I am not happy that Pages was a full year late in shipping. You've heard me say that any number of times. But I wrote 2 books having come through that, and pretty much my whole professional career has been, now I see why this is a problem. Let me help you avoid it. Novelty. Here's a new idea. Hey, let's implement it. And if you have a high-performance organization, the cost of implementation is small. It's like, let's try this out. Oh, this works great. Or, let's try this out. Oh, this sucks. Let's roll it back in. Back out. Yes?
I was confused on what bridging was again.
Cross-cooperation among groups that have different responsibilities. So maybe you have a company that's got 2 or 3 different apps. You've got teams for each app. And cross-bridging or cross-fertilization means you guys talk to each other. Say, hey, we discovered this. Oh, that's great. If we do this in our app, you can do this in your app. Of course, we're going to talk about coupling when we talk about architecture in a minute. So let's back up. Talked about, the thing here is that continuous delivery and lean management both impact for good organizational culture. Go read your books. Okay, technical practices. They focus on continuous delivery. You'll usually see continuous delivery and continuous integration lumped in together. You'll see CD, CI, or CI, CD. But right now I'm just going to follow their terminology and focus on continuous delivery. You want to make changes safely, quickly, and sustainably. Remember the arc of engineering and how software starts to rot after a certain number of changes? Goal of CI/CD is to keep it from bending down. You want to continue to improve, but maintain the quality and the changeability of the code. What's it require? Well, what it requires actually is a significant organizational change. And it's why these efforts usually start out stupid and work up from there. You want to start out small. Start out with small pilot projects and grow this slowly and gradually as you prove it and make it go viral within the organization. Need to build quality and work in small batches. In other words, you're not making massive changes. The whole idea of continuous delivery is that you make small changes repeatedly. So that at any one time, you've made a small change, which means the amount of testing you have to do, the likelihood of introducing new errors is less. And you get it out there and it works, and then you can make the next small change. Use computers for repetitive tasks and humans to solve problems. This is actually another aspect of the COTS versus custom stuff. You want computers to do the stuff that computers do best. You want highly automated configuration management. You want highly automated testing. You want the things that computers can do fast and they will do repetitively and error-free. You want humans to solve the problems. Back to the armor graph with all the false paths, that's where the humans can do the work. And relentlessly pursue continuous improvement, which we talked about. Everyone is responsible. You don't have finger pointing. This is why failure doesn't lead to scapegoating or justice. It leads to inquiry. It's like, okay, this went wrong. Why did this go wrong? What changes do we need to do to make sure it doesn't go wrong again? Or how can we reduce the risk of problem or failure? So what you've got is comprehensive configuration management, which means all of your source code management, all of your build management, all of your deliverables are in an automated system so that you can say, build 1102 has a problem, let's go back and rebuild build 1101 and push that back out. And you should be able to do that with 2 clicks. Or 1 or something. That's what it requires. Continuous integration. This refers to the fact that the typical practice, here's your source code trunk, your main repository. And a developer at this date says, I'm going to take a snapshot of this and I'm going to make changes, and then 3 weeks later I'm going to go back and try to reintegrate my changes with the trunk for development. And you've got another developer here who does the same thing and tries to reintegrate here, and you've got another developer here, does the same thing, tries to reintegrate it here. That's not continuous integration. But this is the common practice. Continuous integration is here's the trunk. I'm a developer. I grab a snapshot. I make small changes, I test, and I reintegrate the same day. Or maybe a day or 2 later. In other words, you are continually reintegrating back here. You're not holding on to code and making more and more changes over a period of days or weeks. This is also, and where this gap is very small, this becomes what's called trunk-based development. I grab the trunk, I make a change, I push it back. Basically as fast as I can make the change and run all the tests and verify all the highly automated tests and verify what it's doing. Questions? Yes?
That seems similar to what you just said. It's just the amount of time.
Yeah. Continuous integration and trunk-based development are largely synonyms. Some people distinguish them, and you'll see they use trunk-based development elsewhere, but really it's the same thing, yeah.
So basically it makes having your own branch less important because you're just gonna go right back.
Right. The whole point is don't hold on to code. Get back into the trunk as fast as possible so that everyone else has the benefits of what you've got. And then employees. How many have worked on projects where, you know, you go to make changes, you grab the source code, you start making changes, and then you go to reintegrate it, you find someone else has gone through and made a bunch of changes to the source code. You've got to go, yeah, you have to suddenly go up. You suddenly have to go back and reintegrate and rework around and stuff. That's what you're trying to avoid. Right? Trying to keep the changes small, focused, highly tested, and get back in as soon as you can. That's the continuous integration portion. Questions, comments, experiences, horror stories? Anyone? Yes?
One time I pulled up a development branch, and while I was working on that, someone else ran a linter over the whole project. I had like 6 years of code in it, and changed every single file. It was just like space, like changing all the tabs to spaces, and there's a new line in every file. It was terrible to merge it back in.
Oh. My condolences. And yes, this is what life is like. This is why I have these practices. Anyone else? Anyone want to share a horror story before we move on? No. Okay. We'll go. Okay. Now, technical practice. I'm not going to go through all these in detail for a couple of reasons. One is they cover. We're going to cover a few of these in subsequent slides. The rest are going to be covered in subsequent chapters. But these are the practices and technologies that they identify as supporting continuous development. And see, you've got continuous integration and trunk-based development, which really are pretty close to the same thing. I'm sure there are people who have intense arguments on the internet about the difference between continuous integration and trunk-based development. But, you know, guys, you're doing the same thing, just arguing over the gap there. Test automation and test data management are essential. You need heavy, thorough test automation with the test data necessary for it. Yada, 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 yada. We'll be talking about more as we go on. Okay. What they observe is that organizations which have successfully adopted continuous development end up with higher quality. They end up with higher team satisfaction, better organizational culture. Higher performance, again, remember the performance is you're building, testing, and deploying much faster. Strong team identity, we're back to peopleware. One of the things you'll find as you read Accelerate is how much of this ties back into both peopleware and mythical man months. That what they're talking about are practices to help implement the thing. So you get up with a strong team identity, building a team, lower levels of employment pain, reduce team burnout. Burnout typically comes from having to work long hours to achieve stuff you're very unhappy with, or not be sufficiently rewarded for it. The nice thing about CI/CD, as you implement it, is that you're sharing the risk, and you're seeing the progress. You basically have something working every day. Okay, key, architecture. Architecture is important. Who would have thought? Goals, loosely coupled architecture. Tight cohesion within modules, loose coupling among modules. Now, why this is important, we'll skip ahead here, because he brings up Conway's Law. You want your team, and he basically says, as we've talked about in class, you want to organize your team around the desired architecture. The desired architecture is loosely coupled. Why is that important? Because if your architecture has a series of subsystems or modules that are loosely coupled, then the person or teams responsible for each module can operate quickly, independently of everyone else, which opens the door for continuous integration. Let me go back here. Here are the things. If you have a truly, well, the two biggest goals is we can do most of our testing without requiring an integrated environment, and we can deploy our application independent of other applications and services it relies upon. That requires loose coupling. In other words, I don't care what you're doing as long as you're adhering to the API, both the formal and deep API, vice versa. So if I suddenly want to run Lent or whatever, and reformat all my code, I'm not messing with yours because you really don't care as long as I'm adhering to the contract. That's between our particular systems. So, what you want to be able to do, and when we're talking about apps here, the term I'm talking about the module that you're working with within the architecture. You want to be able to make large-scale changes without the permission of someone else outside the team. In other words, again, as long as you're adhering to your mutually understood API, you can say, you know, we're going to do some significant refactoring here. I'm going to rechange this. We have a much better way of approaching this to help improve our performance. And everyone else doesn't care because your particular app, your module, whatever, continues to work the same way. Likewise, you can make design changes that depending upon or creating work for other teams. You can complete your work without having to communicate and coordinate people outside the team, unless, of course, you end up changing your API process. You can deploy or release your particular module on demand. You can do your testing on demand with that integrated test, so it's up there. And if this is all true, then you can perform deployment during business hours with negligible downtime. Again, this is what Amazon does, this is what Facebook does, what a lot of online systems now do. They will do multiple deployments a day and change stuff. Most of it you won't see if they do a bad deployment or if someone gets really creative. It's like, why doesn't this work this way anymore? You know, sometimes it's for the better and sometimes just swear and move on. So a loosely coupled architecture enables organizational scaling. Now, Brooks' Law, adding staff to a late project makes it later. But if you have, and what's the primary reason for Brooks' Law?
Catching people up.
Yeah, getting people up to speed with communication. So if you have a loosely coupled architecture, and you decide you're going to add a new module, and you hire people because this will add new functionality, that does not affect anyone over here. You don't have communications. You don't have, aside from whatever the interface is here, you don't have communications. These people can take whatever time they want to come up to speed, but these 3 modules just continue on their merry way. And when this one's ready to start providing a new service to the others, they say, oh, that's nice, and we'll start making use of it. So this is a way, under some circumstances, to break Brooks' Law, to actually be able to significantly increase functionality by adding people. They have a chapter or section on how teams should be allowed to choose their own tools within reason. They say teams should choose their own rules. They said, well, actually, for a lot of tools, you want to have standardization within the organizations. You can sort of choose your own tools, unless you can. And the architect should focus on the engineers and outcomes, not tools and technologies. Now, it is a common failing of software architects, and I've been a software architect for many years, say, oh, there's this neat new approach, there's this neat new tool, we're going to build it this way, we're going to use this particular technology, and so on. Their argument is that the architect should be talking about how do I architect this to help the engineers achieve continuous delivery and help the organization to achieve continuous delivery. What tools or technologies you use are irrelevant if the people who must use them hate using them, or if they don't achieve the outcomes. Yeah. Okay, now I'm going to ask for, I know a few of you have horror stories on this because I think you've told me before. How many have been in an organization where the head programmer / chief architect / CTO made some technology decision that made your life worse? as a developer. Anyone got a story for that they'd like to share? Oh, come on, I know something. Mention somewhere. Okay, well, yes.
We were told to write this particular program in Scala, and it used like 4 gigabytes of memory. And later on, we rewrote it using Go, and now we use like 64 megabytes.
This is sort of like the one I told about where they were doing the conversion from EBCDIC to ASCII, and they were using everything had to be distributed objects. It was Corba, so they had an actual distributed object that actually did this EBCDIC to ASCII conversion. It was 1,000 times too slow. We, meaning OSG, brought in a consultant who rewrote it in 10 lines of C with a lookup table and ran 100 times faster. And it had a much smaller memory footprint as well. Integrating information security. Now this whole chapter pretty much takes the same approach for information security as in my Inside Out lecture or my diagram on quality assurance. And the problem is that for a lot of organizations, they treat security the same way they treat quality assurance, something you do for a few weeks at the end. And their argument is, oh no, you need to design it in from the very start. You need to make sure that, and they have this rugged manifesto, which I'll let you go through and read. So they want you to design it in at the very start, which makes a lot of sense. And yet, an awful lot of organizations don't think about the security of their software. They really don't. It's why you have news stories, pretty much weekly about 38 million user records suddenly leaking out onto the web. And it really does strongly parallel the same lackadaisical approach to quality assurance. That's chapters 1 through 6. We'll talk about the other assigned chapters next week. Let's go ahead and take a break now. Come back at 10 till. We'll start again. We can get out there before everyone takes their break. And I'll try to push through the rest of this and get you out of here by 3:30.